So far in this preview, you've probably seen some things that are familiar and some other things that are unfamiliar. One thing that's almost certain familiar is the coding style that we'll use. And this is based on something called the design recipe, which has come out of the literature on functional programming. So in short, the thing to keep in mind with the design recipe is that code structure follows type structure. The way that a piece of code is organized needs to match the way that the type that the code processes is organized. So for example, we've got our type shape here. We've added a third variant to shape. So a shape is now a circle, a rectangle, or an adjacent pair of shapes. With this third variant, the shape type is now recursive. It points back to itself. So when we have a function that processes shapes like area down below, first, the function needs to have three match clauses to match up with the three variants inside the type. And then second, in the same places that the type is recursive, the function also needs to be recursive and point back to itself to handle those little shapes inside the adjacent variant. So again, data type and function shape need to match up with this coding style. And we'll see that it's an important concept for writing clean and maintainable code. Here's a rough outline for the course. We'll start off with a warm-up to functional programming. Then we'll get familiar with interpreters, which we'll be using for the rest of the semester to implement concepts. Our first batch of concepts will come from state, and then we'll see different kinds of control. We'll spend a little time looking at compilation and garbage collection. Then we'll move to objects and classes. Then we'll study type checkers, and we'll see how a type checker is an abstract kind of interpreter. And then finally, we'll end the course with a look at macros, language extensibility, and the racket sense. And then we'll talk more about the big picture of programming languages moving beyond Shplait.